Hello everyone, welcome to lesson 9-5, Measures of Variation. In this lesson, we will continue to address the essential question, how are patterns used when comparing two quantities? And we will use the vocabulary mean absolute deviation and standard deviation. Let's have a look at a real world example and see how this lesson fits into the real world. Let's look at the context of a restaurant. A restaurant asks the staff to record the number of people who order the special each day. The table shows the number of specials ordered per day. So at the very top, we have the days 1 to 6. So this is our x value, our independent variable. And then our number of specials on day 1, 26, day 2, 25, day 3, 30, and so on, as you can see. Question 1. Plot the data on the graph provided. So we already know how to plot these points, and I want you to pay attention here. On the y-axis we have a little squiggly line. That squiggly line is called a break, and it's a break in the y-axis that represents that the values have been crunched, because you see here we're jumping by 20 units or 20 orders in just one frame or in one square. But then after that, we increase by 5. So what we're trying to represent is that we have no data between 0 and 20. So we start from 20 and we progressively or gradually increase by 5s. Okay, so this break just represents that data has been crunched in there. And okay, so if we plot our points at 1 and 26 and so on, they will look like this, where we have 1 at 25, 1 at 26, 2 at 25, 3 at 30, 4 at 32, 5 at 27, and 6 at 28. Number 2, find the mean of the data. Remember, to find the mean, we have to add all our values in the y, add all our values and divide it by the number of values. So we would add 26 plus 25 plus 30 plus 32 plus 27 plus 28, which is 168, and we're going to divide it by 6 because there are 6 values, and we get 28. So our mean is 28. Question 3. Complete the table by finding the absolute value of the difference between the mean and each data value in the set. Now, absolute value just refers to the distance from a number. Normally we work with 0. So when we work with absolute value, we're just identifying the distance from 0 in the positive or negative direction. It doesn't matter if it's positive or negative. Absolute value is just the number of units away from 0. But in this case, they're telling us from the mean, so the 28. So the number of specials on 26, the difference from the mean. How far? What's the difference between 28 and 26? It's 2. What's the difference between 28 and 25? 3. 28 and 30? 2. 28 and 32? 4. 28 and 1? 28 and 27? 1. And 28 and 28? 0. Find the average of the values for the difference from the mean to the table. So again, we're going to add all of these up. 2 plus 3 is 5, plus 2 is 7, plus 4 is 11, plus 1 is 12, and we're going to divide that by 6 values because there's 6 of them. And 12 divided by 6 is 2. So essentially there is a range of about 2, an average range of about 2 from the average of all the specials. Now, what do we mean by mean absolute deviation? So essentially what we just did, we find the mean and we find an absolute value or an absolute deviation. How far does it deviate from the average? You have used measures of center to describe the middle of a set of data. And you have used range to describe the spread of or variation of a set of data. Another way to describe the variation of a set of data is to use its mean absolute deviation. The mean absolute deviation of a set of data is the average distance between each data value and the mean. So let's have a look at an example here. And essentially it'll be very similar to the one we did in the first page, in the beginning of the video. The table shows the heights of the first 8 people standing in line to ride a roller coaster. Find the mean absolute deviation of the set of data. Describe what the mean absolute deviation represents. So here's the height of all the people, and they're all in inches. 52 inches, 59, 48, 54, 60, 58, 55, 62. We're going to find the mean. So we find the sum of all those numbers, and we divide it by the number of values. So we have 8 values here, 8 different numbers. So we're going to divide it by that. And we get an average of 56 at mean. Now we're going to find the absolute value of the difference between each value in the data set and the mean. So we're going to find the distance from the mean, the average, to each one of these values. And that's what we do. And remember, we do it in absolute value because we're not doing negative nor positive. We're simply trying to find how far the number is. How many numbers apart. And we get 52. What's the difference between 52 and 56? 4. 48 and 56? 8. Notice the format. It is between the absolute value symbol, the parameters. Okay, so that we're not getting -4 because we're working with an absolute value. We're simply just getting 4 numbers apart. 8, 4, 1, 3, 2, 2, and 6. Now we're going to take these numbers, find the sum of those numbers, and divide it by the number of numbers. We have 8 values here, so we will divide it by 8 after we find the sum. And we find a mixed number or a decimal number, 3.75. So that means the mean absolute deviation is 3.75. This means that the average distance each person's height is from the mean height is 3.75 inches. Meaning that it ranges. If the middle person, okay, is 56 inches tall and they stand here at 56, right? We can have a range, okay, a range that can deviate, or I should say, we can have a person taller or a person that's shorter, and on average, the shorter person and the taller person will be 3.75 inches apart from the middle person. Okay, now we get to try it. A. The number of points that Samantha scored in 5 basketball games was 8, 14, 10, 7, and 13. Find the mean absolute deviation of the set of data. Describe what the mean absolute deviation represents. Okay, so first let's find the average, the mean. Step 1. We find the sum of all these numbers, and then we're going to divide it by the number of numbers, which is 5 of them. And I get 52 when I add all those numbers divided by 5. And that is 10.4. Okay? 10.4 is the average number of points scored by Samantha, as you can see here. Okay? 10.4 per game. It's the average. Now we're going to use that average to find the mean absolute deviation. So for step 2, I'll do step 2 right here. We're going to find the absolute value or the absolute difference from each one. So from 8, so you would do this. From 8, find the difference for 10.4. Okay? You would do the same thing for 14 to 10.4. And the same for 10. Find the difference of 10.4. Okay, and when we do that to all the numbers, I get, for the first number, I get a deviation of 2.4, because the difference between 8 and 10.4 is 2.4. Then it looks like I get 3.6 from 14 to 10.4. Then between 10 and 0.4, I get 0.4. And then from 7 to 10.4, I get 3.4. I'm just doing these mentally quickly here. And from 13 to 10.4, I get 2.6. Right? I'm going to add all of these values and divide it again by the number of values, divided by 5. It's getting a little messy, so I'm going to erase some of it. So again, I have 2.4 plus 3.6 plus 0.4 plus 3.4 plus 2.6, and all of that will be divided by 5 because there's 5 values. And I get 12.4 divided by 5, and that's going to give me 2.48. So I have the average distance each data value is from the mean is 2.8 points. Let me write that out for you so you can write it in your notes. And again, I'll repeat it. Therefore, the average distance each data value is from the mean is 2.48 points. So describe what the mean absolute value deviation, the mean absolute deviation represents. It represents that the range from the average points scored in the basketball games is 2.48 or 2.5 points. That's how much it deviates by from the average. So that was mean absolute deviation. Now let's take a look at standard deviation. The standard deviation of a set of data is a calculated value that shows how the data deviates from the mean of the data. In a given set of data, most of the values fall within one standard deviation of the mean. So, if the mean of a set of data is 21 and the standard deviation is 3.5, then most of the values fall between 21 minus 3.5 or 17.5 and 21 plus 3.5, or you could say 24.5, which means it will go up by 3.5 or down by 3.5. And you can see it here in this illustration. If the mean is 21, it can go as high up as 24.5, which is going up by 3.5, or it can go down to 17.5, again going down by 3.5. So it can range from the mean by 3.5. Let's have a look at how this is different from mean absolute deviation. So we're going to look at standard deviation. The standard deviation of a quiz course for Class A is about 1.2. Describe the quiz scores that are within one standard deviation of the mean. So what is the mean? Let's see here. We add all of these scores. Once we've added all these scores, we're going to divide it by the number of scores, how many there are in total. And it looks like we have 4 by 3, so 12. Once we add all of these, and you can see they did that here in step 1, they're going to add them all, dot, dot, dot. So all 12 values are included here. They find the sum, and then they divide it by 12. They get 8.25. That's the average score for the quiz. Then in step 2, now that you have that score, find the range of values that are within one standard deviation of the mean. Now that you have your average, you either subtract 1.2 or you add 1.2, and you get this standard deviation from 7.05 to 9.45. Okay, so essentially you're being given the standard deviation of a quiz. It deviates, it ranges by 1.2 down or up. So quiz scores that are between 7.05 and 9.45 points are within one standard deviation of the mean. And this is our last example right before the guided practice. It's a shorter video today with less examples because we're just learning two skills, mean absolute deviation and standard deviation. So let's have a look here for standard deviation. The standard deviation of a quiz course for Class B is about 1.9. Describe the quiz scores that are within one standard deviation of the mean. So are we using the same numbers from the previous example? No, we're not. It doesn't look like it, so we actually have to find the average. So let's find the sum and divide it by the number of values, which is 12. So when we find the sum and we divide it by 12, we get 7.5. That is our mean or our average. So we can take 7.5 and subtract 1.9, which is our standard deviation. Or we can take that same 7.5 and add 1.9. So we're going to get 7.5 minus 1.9. We take away 1 from 6, that makes it 6.5. I get 5.6 here, 5.6. And 7.5 plus 1.9, I get 9.4. So what do we have? Therefore, it looks like we have the quiz scores that are between 5.6 and 9.4 are within one standard deviation of the mean. Again, let me write that down for you. The quiz scores that are between 5.6 and 9.4 are within one standard deviation of the mean. Okay, everyone, that is it for today's lesson. I will see you for the guided practice. Bye-bye.